Welcome back, everyone. In this video, we are only going to talk about something really vitally important to programming, and that is called a function. Now, they're sometimes referred to as methods, and really they are absolutely identical to functions. It's just really the difference is where they originate from. But in this video, what we're going to do is we're actually going to create our own functions, our own custom functions in Python. So let's get back over to Visual Studio and begin doing that now. So we've already seen some functions. So print is a function that we've used many times. And the reason we know it's a function is because we put the round brackets after it. We've also used round. We've done ABS. We've used this one. We've done range. We've done a bunch of different functions already, and these are library functions. So going forward in this video series, I'm not going to be too picky if you view this really as a method or a function. I think really the difference becomes where the function originates. Is it a library function? Is it a custom function that you created? Or is it part of a class? And we haven't got to classes yet. But to be honest, going forward from now on, I'm really just going to refer to all of them as functions. It doesn't really matter to me where they come from because functions and methods are created the exact same way. Doesn't matter if I'm a Python developer for Python themselves that are adding to the libraries, or if I'm just building my own custom Python applications. They are built exactly the same way and they do exactly the same thing. So going forward, I'm going to refer to them just as functions. Before we actually go and start defining our own functions, there's one little important piece of theory that I really need to cover with you. It's vitally important that you do understand this. Now, remember long ago when we were talking about variables, and I said that variables are nouns. They are the grammatical equivalent to nouns, and we name our nouns as singular words. You know, for example, age is singular. It is a noun. Dog is singular. It is a noun. But when we talk about functions, this is the difference here also, is that functions are verbs. So you have to understand that. So when we did, for example, print is a verb, and a verb is an action word. Okay, so we have nouns, which are person, place, or thing. And then we have verbs, and verbs are action words. Now, typically, it is the noun that performs the action or the verb. Okay, so it's a grammatical trick, I'm sure, in coding, but you have to understand that there is that relationship between nouns and verbs, like there are variables and functions. Okay, many times, not in every case, but many times, functions need your variables to perform their sort of verb-like operation. So let's go back in and look at an example before we start defining our own functions. So again, as we look at this, we are calling a verb when we call a function. So we're saying print. Print is a verb. It is directing an action. When we say round, we are saying go and round out a number. So these are verbs that we are enacting. And notice this isn't pluralized or anything like that. It's a verb, okay? So let's look at an example of creating our own function, how we would go about creating our own function. So when we want to do our own custom functions, the way we have to start this is we have to say def, define. And this is sort of the prefix that we have to use to tell the compiler that, hey, we're about to create our own custom function. So we're gonna say welcome. Okay, and this is what our custom function is going to be called, welcome. And of course I spelt it wrong. So welcome. And we need the two brackets. That is a must. We need the def, and we need those two brackets at the end of the word. Now, welcome is a verb. And if you're not sure if it's really a verb grammatically, in English, the way to tell if something is a verb is to add the word to just before it. So if you say to welcome, and that makes sense to you, you know that that's a verb. Okay, so we're going to do this. And of course, just like we've seen before, we have to add the colon at the end of that. And when we do that, everything after that can be written inside that block of code. Okay, so I'm going to write print, and inside I'm going to type out a string. This is going to be a welcoming message, and it's going to be hello. And the next one I'm going to put is print. And how about how are you? With a question mark. Okay, so that is my function. That's done. So how do I use this function? Okay, I've gone ahead and I've saved it. And now if I want to actually use it, I have to do something called a function call. It's just the terminology or the lingo that software developers use. They say, call your function. Okay, so the way we do that is we simply just type welcome. And you see that it popped up in the IntelliSense, and I put my brackets there. This tells the computer that I'm calling the welcome function. Okay, so if I try and run this, I'm going to hit save. If I try to run this, you're going to see that it calls whatever I have inside the code block. Okay, and in some programming languages, when you create your function, you end up putting them in these sort of brackets. Okay, and it gets defined like this. But with Python, we don't have to do that. And that would be referred to as its code block. But luckily, we don't have to worry about that when we're writing these functions. And we can just clean all that up. And the indentation is what creates that little code block. The colon here with the indentation is really the equivalent of those two brackets. Okay, so when I want to call that function, all I have to do is type out the name of the function with the brackets, and I'm calling it. So let's go ahead and run this. And you can see that these get output to the screen right now. But I want you to understand something. What is being printed to the screen right now is not these two lines of code. Okay, I know I've said in the beginning that the compiler goes from the top down and it runs the code in a sequence. That is very true. But what's happening here is because I've put the predefined word definition or my prefix def, what it is saying is, hey compiler, there's a function out there somewhere in our code, and therefore bypass what you see here in terms of compiling right now. Just bypass us and then go to the next line. Now it goes to the next line, it calls welcome, and then it says, oh, I remember I walked by something, I bypassed something in the code earlier. Now you're telling me to go back and call that. Okay, so this is what it happens. It bypasses this, and then it goes down, and then it goes, yeah, I remember that. And then when you call it, it's literally, think of it like a phone call. Your line of code on line 6 is making a phone call to def welcome, and it's implementing what's going on in there. Okay, so let me show you something else. Let's say I want to call this function again, welcome. Okay, I can call the function one more time. Okay, and the reason is because this is very, very repeatable code. Let's assume that this welcome function had about 25 lines of code in it. The beauty is this is all reusable. I don't have to do something like this. Okay, I don't have to go do all of this. Every time I want to use these functions, I can write that code one time, and then I can refer back to it as I want. So if I save that and I run this, you can see down below, it's running it again. Okay, and if I do it again, if I do welcome, and I call that one more time, you'll see that it prints to my screen a third time. So we've got hello, how are you? Hello, how are you? Hello, how are you? So this is this code reusability that is so important to us as programmers. Okay, so take a look at this. If you're not comfortable yet with functions, go ahead and practice. It's a really, really important thing that we're doing here. And believe me, this is not the only function we're going to write. We're going to write many functions. And you can see here in print, we passed this string inside the brackets. Well, we're actually coming up next, we're going to start passing in what we call parameters inside those brackets so that we can use that inside of the code logic. And now from the last video, we looked at a lot of our logic. Logic typically goes inside the functions. So before I say too much, let's just move on and look at other examples. So the next thing in functions that I want to talk about is something called an argument. We pass an argument inside of our function. And you've seen this several times with the print function where we put the string in. And arguments are sometimes also known as parameters. Okay, so the word is kind of interchangeable in a sense, but if you hear you're passing an argument or you're passing a parameter, it just means that you're passing something inside the brackets of your function. And the intent of that is so that it can be used inside the body or the code block of your function. So let's go look at another example. Now, looking back at our original example here, what's the difference between the welcome function and say the print function? And you can obviously see that the print function is taking this argument or the parameter. It's actually taking an input, okay? And what happens is we can write functions where we want to have the user or another function or another variable somewhere else get put into there and then get used inside the code block or the body of our function in order to output something else. So let's look at another example with this. Now, I've said that there was a difference between arguments and parameters. Okay, so when we're defining the function itself, we're actually going to put in our parameters. So we're going to say first underscore name and then comma and last underscore name. Okay, so this is my parameter list inside the function definition. And in here now, I can say John as one of my, what we would now refer to as argument. Okay, and when I put that comma in there, you can see the box that comes up. It's telling me, it's prompting me what I need to actually pass into that argument or into that function. It's telling me also with the underline what is next. It says, okay, you've already done first name, but underline because you're missing the last name. So it's trying to help me out. So if I type in dough, you see that I've got two parameters inside the definition of the function. But when I call the function and I use it, I'm offering up an argument. Now, it's really sort of semantic. And don't get too hung up on the details. As you get more experience programming, this is just going to be second nature to you, and you're probably never going to even refer to it as an argument or a parameter unless you're speaking to somebody about it anyway. But just so you know, these are parameters, these are arguments. Doesn't really matter to be perfectly honest with you. So I need to go up to here and modify this somewhat. And I'm going to say hello, and we'll do first name, and we'll do our space in between. And to do this, don't forget I need to put my quotations, and then another plus, and now I'm going to say last name. Okay, so that's the way I would modify that. And another way you could have done this, and I'll do it down below, just for your own sort of examples. If I do hello, and actually I'll take that out. I don't want to use that. I actually want to put F, and inside here I'll say hi, and this is where I'm using the different sort of syntax that we've talked about. So it's first name, and then over here it's last name. Okay, this is the other syntactical way that we could do this. And of course, I've got an imbalance in my quotations. So this is the other way that we could do this, right? So for now, I'm just going to comment out that line, and let's run this code. And you can see that I now have an error in my code. Now, where do you suppose the error is? Actually, everything is fine in the code, but the problem that I've got is that down here, I had this other welcome function. And notice that there's nothing inside my parameter list or my argument list. Okay, I like this one here on line 7, I'm actually passing it. So it is looking for 2 parameters to be passed as arguments. Okay, so on line 7, that function is proper, but here on line 10, syntactically, this is an error because it is an incomplete function. As it stands, this function does not exist. It's looking for it, and it's telling me that my welcome function is missing 2 required positional arguments, first and last. Unfortunately, this doesn't tell me in here which line, but if you look over here, it actually tells me which line I've got my error on. And had I been scrolled down more, I would have seen the red squiggly line. So what I'm going to do is just comment this out for a second. Okay, and then we should get the error going away when we save it. Okay, so now when I go back up and I run this, you can see down here it says, hello, John Doe, how are you? Okay, so let's uncomment this again, and let's call Tom and a comma because it's looking for this other argument, and I'm going to say Jones. Okay, and I'm going to save that. And let's run it. And now you can see that it's running the function the first time, and then I'm calling the next function and I'm passing in a different argument list. Now, again, going back to why would I do this? And I hope that it's clear to you now that I only ever wrote this function one time. And when I call the function repetitively, I can change the parameter list. So think of it like a little mini program inside of a program. In some languages, they refer to these as subroutines. Okay, so instead of, doing where I need to take all this, copy it, and paste it in order to print out Tom Jones, what I'm allowed to do is create this little tiny subprogram inside my overall program to perform this function that I want to repetitively use. Okay, so that's the value of functions. These are these tiny little modules that we want to have to repeat that code over and over and have a different outcome based on what we tell it as an argument. Okay, so this is really important. So let's now turn our attention to the different types of functions. In Python, we actually have 2 types of functions. And the first one is a function that performs a task. And the second one is one that returns a value back to us. And an example of, let's say, performing a task is the print function. It outputs, how are you, to the screen. It just performed a small little task. But another example of returning a value is when, let's say, the round function will take what is input and return. It'll do some sort of a calculation or some sort of functionality that'll perform. It'll do something. It'll perform an action, and then it will return the result of that to us. So you have ones that just perform a straightforward task like print how are you to the screen, and the other one is do some processing in the background and then take the result and give me the result of all that work that you've done. Okay, so let's go look at examples again. Let's look at this example in this function right here. It's just a modification of our last welcome function. And I have this one parameter and its name. And remember what I said about going from the top down with the functions and your compiler. Notice I do have this print statement here. It says hello plus name. And if I go and run this, maybe, if you're just starting out with Python, you're expecting that this line is, going to read from the top and go down and print out, at the very least, hello with a space in it. So let's just go ahead and run this, and you'll see that it doesn't actually print out anything to the screen, because remember, it's a function, and your compiler sees this def right here, and it tells it, okay, bypass this function. So let's go ahead and actually do another function, and we're going to type a function with a return type. So the top one, is the first function that we talked, where it's performing a basic rudimentary task. Okay, now let's do this one with a return type. So if I do def and I say get welcome, okay, and then I'm gonna put in another parameter name in here, and don't forget that colon at the end. Now what I want to do is I want to return this statement here, this hi with a space, and then I'm going to say name. Okay. So now I can call this function get welcome. And what's really interesting about this is when this get welcome function execute, it's going to do something and return something back. That is why there's the keyword return on line 5. So if I want to get this, so I'm going to say get welcome. And in this, I'm going to just type in Tom. Okay. So how do I return that now? How do I process that? First, I want to draw your attention to this first welcome function here. And notice I've chosen to write the name hello. In the second function that we wrote, I've typed in hi. I just want to point your attention to the difference between the two, because in all honesty, they look very similar and they're kind of going to do the same thing. But how do I process this one here? Inside my get welcome function, there's no print like there is in the welcome function up here above. And one of the things I can do is I can do a message, and I can assign that whole get welcome to an actual, I can actually assign that now to a variable, which is message. Okay. And now if I want to call that, and what if I do this welcome, and inside here, instead of actually typing in a name, maybe I do message. Okay. And by looking at this one, which function do you think is going to be called? So I'm going to save that and I'm going to run that. And you'll see that hello, hi, Tom is actually getting called. So it's pretty interesting because what we're getting is an actual hybrid between both of these functions. Okay, so functions, again, they take getting used to. They take a little bit of experience. And what's happened is I've actually run a function, taken the returned value, and that's the important thing is I have processed this and I've created a return value from this line here. And from the return, what I was given. Then I assigned it to this variable name, and then I called the other function, the welcome function, which is now, in a sense, I'm passing this whole entire variable as my name. And then it's going back into the function and it's outputting name. In a sense, what it's really doing is replacing name with message. So that's kind of what's happening there. Okay, so that seems a little bit like a dog chasing its tail, and I fully appreciate that. You just have to start to get comfortable with functions. They're never going to go away for as long as you're a programmer. And in the future, when we start writing our own classes, we are going to be defining a whole bunch of different definitions or functions within our class. And we are going to be using all of the variables or the nouns inside that class. So I know that seems a little bit confusing if you're just starting out in programming or even Python, but you have to understand there's two types. There's, one's like this welcome function, and then there's the other one that actually returns a value. Okay, so let's keep going and look at some of the keywords in our arguments. Let's look at an example of this keyword here. But first, I want to create this function for you, and I'm going to call this increment. And in my increment function, I'm going to pass, or I'm going to have two parameters, and okay, and don't forget the colon at the end. And then I'm going to say return. So when you have this keyword return, this implies that you're going to do something, perform some sort of functionality. Okay, and then once that operation or that functionality is completed, then you're saying, take the result of that and give it back to me. So I'm going to say number and add it to by. Okay, and that's all I want to do for this. So now if I want to call this function, I want to actually use this function, I'm just going to call it. So I can go into here and I'm going to now pass it two arguments. So let's say 5 and 2. Okay, that's all I've done. And now look at this word here. If I want to do an output to this, I actually have to, put it into some sort of a variable name. And like I said before, that when I do this calculation or I perform this operation, I want to do a return, but what I'm doing is I'm returning the result of that. So typically you will see in a lot of programming languages kind of a technique as people will use the word result, and they'll spell it properly. They'll spell result, and what you can do is now assign that. So I'm going to assign this result into a variable. And now, I want to give you a little bit of a tip. If you were looking to work with functions or call functions, always start your line of code with the function itself, determine that you want to call it, and then start enhancing it after that. Okay, so now the next thing I want to do is if I want to see the result to that, I'm just going to do a print statement, and inside my print, I'm just going to call result. Okay, so let's have a look at what the result of this is going to be. Okay, so I press, I'm running it, and you can see that the result right here is in fact 7. Okay, so all we did is we had these two arguments, we passed in, two parameters, and we passed in two arguments. We processed that, and then we took the result of that and we returned it. And who did we return it to? Well, we returned it to this variable right now. And of course, the returned result of that is now just printed out to our console. But I want to show you one more thing. We don't necessarily in Python need to do this. Okay, so I showed you that just so you have a good understanding of what's going on, but we don't really need to do that. What we can actually do is, instead of having the word result, I can actually now put this function inside of my print function, and I'm just wrapping my print function around that. So I'm still getting the result. I'm still returning it. Okay, I'm just going to call it inside here. And if I save that, and you can see that my PEP8, when I saved it, dealt with my formatting, and you can see that right after my function, I've got 2 line spaces. Okay, so if I go ahead and I run this, let me change the value just for comparison. So I'll change that to 3. I'll save it, and I'm going to run it. And you can see now that 8 appeared on the screen, whereas previous to that, our value was 7. So we know that it's actually working. Now, if you really come across this code and you think, you know, that's not very obvious to me, it's not very clear, because let's suppose that you have a great distance in your code. You don't even know where the increment function was written. It's somewhere in your file, but you want to know the details of it. Okay, but right now you don't really have any details of it. Okay, you go through here, you don't really know what's going on. What you can do is you can go into your argument list, and you can create these keyword arguments. And what I can do is, remember, I called this one by, and so I can just type in to help myself in the future or other programmers, and I can do this. I can kind of identify or restate what this is, or the label of what this is. I can sort of give people, it's almost like giving people hints or clues. And so now I know what this is. I'm incrementing 5 by the number 3. So if I do this by 4, and I change this, and I save it, oops, yeah, and I save it, it still works just fine. Okay, so you're seeing now that I've added this 5. So when they see the result, they're gonna go, okay, it's not necessarily just incrementing, it's actually doing a different kind of a calculation. It looks more like an add to me. So this is a little kind of a keyword argument hint that you can put into your Python code. Now I want to take a minute to talk about default arguments. You remember earlier where I tried to call the welcome function and I had arguments in it, but down below we couldn't see on the screen the second welcome function call that had no parameters or no arguments placed in it. And we got an error because it was looking for it. So we can kind of do something here to kind of trick our parameter list a little bit. And the one thing that I can do is I can go up into here and I can say equals, let's say 1. I'll change it to 1. And then I can go down into my actual parameter list or my argument list and actually omit this. By putting in this keyword with the equal, I'm just basically sort of defaulting that. That is the default action. And the only thing that I'm going to really be interested in changing is the very first argument. Okay, so if I go ahead and I save that and then I run it, you can see that it still actually runs. Okay, so this is a really kind of weird thing. My personal preference is that maybe you don't do this. That if you are going to specify 2 parameters, then you keep your code nice and clean and less confusing, because in the future somebody's going to come along and say, wow, why am I missing a parameter? But this is sort of the power of commenting. You can put commenting in there and say, there are actually 2 arguments to this function. You could do that if you really want to leave notes for your future self. But you know what? That's not the most efficient way of doing programming. So I just wanted to show you that this is an option available to you if you choose to do that. Now, if I go in and I change this to 10, okay, I'm only updating that. And then I press save and I run this, I get a result of 11 down here. Okay, so this is a pretty important thing. By default, we're going to increment by 1. I never have to change that. if I'm only interested in changing the first argument, then you can just type that in there. Okay. But here's one more really interesting fact about this. Let's say I actually want to have I want to change my parameter and I want to increase that by let's say 2. Okay, I can still go in. It's still perfectly legal that I actually do this. This is just setting a default starting value. And what I can do is actually put it in there later on if I want to. And then I'll run this and you can see right here that it does in fact still update. So these are different ways that you can manipulate your default arguments if you want to. Now, one last thing that I want to tell you. This is referred to as a required parameter. This you have to pass in. And all of your required parameters have to be before your default parameter. Okay, so I'm not allowed to do this, some other. Okay, I'm not allowed to put that in there. Okay, unless I do, if I did something like this, equals, let's say 6. Okay, then I'm allowed to do that. I can have my defaults in there, and then I can do whatever manipulation. But all I'm saying is anything with your variable name and the equals becomes your default. All your defaults must come after your non-default or user input or required parameters. Now let's look at an example where we have a function and we want it to do some mathematical operation, and we start to write this function to do the calculation, and then later on we want it to actually do some more. So what I can do is I'm going to do this def. Okay, and of course I spelled that wrong like I always do because I have fat finger syndrome when I'm trying to type and talk. And so in here what I'm going to do is I'm going to say A, B, and put my colon in there. And now I want it to do a calculation. So I want to do a return, and I want A to be multiplied by B. Okay, so that's all it does. It's going to perform whatever this calculation is. So if I go down to two more lines, and I want to call this now. I want to call my multiplication function, and I'm going to pass in 10, comma 10. Okay, so I want it to say, what is 10 times 10? Okay, but what if in that multiplication I realize, oh, you know what, I have more numbers that I want to do. Maybe I want to do, then I want to multiply it by 5, and then I want to multiply that answer by another 2. Okay, what happens when I have this situation? So what I can do is something really interesting. I can just put in, let's say, for example, now I can't use inputs. Inputs is a keyword. Let's do numbers. Okay, I don't know how many I want to use, but what I can do is I can put the asterisks right in front of that. And this is sort of some magic associated with Python that I can actually go in there and do this. So let me just comment out this line for a second. We'll come back to it. And I'm just going to print out this numbers right here. Okay, I'm just going to print that out. And you can see on line 6, when I call my function, I have a whole bunch of numbers in there that I'm trying to pass through. So if I run this program, you can see what I'm getting. It's actually printing out the entire parameter list inside brackets. Okay, so what I want to do is just give myself a little bit of space up top. And remember, in the past, I talked about something called a list, and it goes in square brackets. So if I were to say 5, 6, 7, 8, okay, this was a list. And the difference really between what you're seeing here and this here is just really the syntax that I'm using. I'm using square brackets. This denotes that it's a list. And believe it or not, with the round brackets, this is actually a tuple. And in the future, we are actually going to do a whole video dedicated to data structures. So don't get too concerned about this right now. Just know that, there is a difference in the capabilities of these two things. So this is a list and this is a tuple. The big difference is I can't add a new number or a new object to the tuple, but I can to the list. Now, the great thing is that we can iterate over them, and I don't need that line anymore. So what I can do is I can change this. Let's just go below this here. And now I can do a for loop. I can say for number in numbers. Okay, and you can see what's happening there. And don't forget, it's a for loop, so I've got to put my colon in there. And when I save that, you'll see that I'm getting this error underneath, right? And the reason is because my formatting, I've got the colon, which tells me I need to do some indentation on my very next line. Okay, and I'm going to save that. And you can see I still do have a problem. Okay, and let's go look at what the problem is. It's this unused variable number. Okay, and that's okay for now. We're going to fix that. And I don't know if you saw what the error was, and I wanted to leave it in there because it doesn't, there's oftentimes you have to be careful. Now notice I have an S on this one and I have no S. This is singular, this is plural. But which one do I want to print out? And that's where the error arises. Okay, so be careful in sort of your internal logic inside your mind on what it is you're really trying to do. So I'm going to save that, and you see that the problem is actually going away. Okay, and let me clean this up so that, it looks a little bit better for us. And now let's go ahead and run this. And you can see right here, 10, 10, 5, and 2. And also notice the difference in the formatting. Now, if I want to iterate over this, and I'm going to take that out of there altogether, I can create this variable, and we're going to call it total, and set it to 1. So this total is set to 1. And let me take that out of there as well. Let me just move it down. And now I can do total is actually equal to total, and then multiply by my number. Now, which number is it that I want? Is it numbers or number? And it's actually number, okay? No different than before. Now, the other way that we could write this is I can say total, which is times equal number. Okay, and I'm going to let you decide on what you want to do. I personally don't like to do it the way it's seen on line 5. And the reason is I just think that it makes a lot more sense to understand what the full operation is going on. When I look at it this way, I realize, okay, I'm multiplying times by number. This is the way I've been doing it since I was 5 years old. So this is what my brain automatically interprets. This, with a lot of years of experience, you can understand what's going on. I just don't personally think that it's as readable as line number 4. So you can do it however you want, but I need to show you how either method is done. So I'm going to comment this out. So we're going to do this a slightly different way, and I'm going to take this out of here just so that I can have more screen space. And there's one more thing that we do have to do, and that is to do a return statement. And we're going to return the result of total. Now, remember what we talked about with formatting and indentation. Because I am in a for loop right now, what's going to happen in its current state is it is going to constantly do this and then return a value. That would be incorrect for what I want. I want the for loop to constantly go through and finish executing and then give me the final result. Okay, so what I need to do is make sure that that return statement is always on the same level as my total, or as my for loop. It's the only way to break out of this for loop and then have a finalized total at the very end. Okay, so that's a really important thing. Don't make that mistake. Your return value has to be on the same sort of vertical line or indentation as your for loop. Now, one thing I'm going to do here is I'm just going to print this, and I'm going to wrap this in a print function. And this is what we're going to see. So what's happening is this entire function is being executed. It's returning a value, and then that final value is what's going to be output to the screen. So I'm going to go ahead and save that. I'm going to clean that so I get a better looking output. And you can see the output is actually 1,000 now. Okay, so that's 10 times 10, which is 100, times 5, which is 50, and 50 times 2 is 1,000. Okay, let's just change the parameter list a little bit more. Let's say 1, 2, 3, and 4. And let's run this again. And you can see after I saved it, the final output is 24. This is a great opportunity to actually introduce a different style of argument list and talk just a little bit about something called a dictionary. And this is a good sort of section to combine the two topics. So let's say we do def for our function, and we're going to say save user and info. Okay, and in here I've got this my brackets that I've got to put in there, and I'm going to use 2 asterisks, and I'm going to type in user. Okay, and this is really important, and let's not forget our colon at the end of that. Now I'm going to type in print. I'm just going to do a print function, and I want user. Okay, that's all I'm doing. This is the only thing I want within the function. And so if I save that, and I'm going to go down, and I'm going to now call this function. So I want to say save user info, but notice I haven't actually defined any kind of a argument list in here. I've just done 2 asterisks with the word user. So what I can do in here is now I can do ID equals 1 for user number 1 that I'm passing in as an actual argument, and I can say first name is equal to, let's say equal to John. Okay. Could you imagine if your name was actually John Doe? I think you'd have the most cruel parents known to man. And then last name. Okay. Last name is actually going to be set to Doe. Okay. So if I go and I run this, and I'm going to save that, and I'm going to run this. And look at the output right here. Okay, and this is where we're getting our dictionary. And what it is telling us is we have something called a key value pair. And don't worry, we're going to get into dictionaries in the future as well. This isn't something that can be lightly glossed over. We have to spend more time on dictionaries. So if we say ID of 1, first name is John, last name is Doe. Okay, so this is how we would go about doing that. Notice it's this double asterisk here that we've defined inside our parameter list. Okay. So really important to understand. And one more thing I want to do, I want to actually add one more thing, because I also want you to realize that I can constantly mix and match this. I can add to it. So let's say age, John Doe's age is going to be 20 years old. Okay. And let's save that. You notice that change that formatting automatically. And I'm going to run that one more time. And there it added the key value pair age to the previous line 5. We can also do something here up in our print statement. And if I want to access individual items inside that dictionary, what I can do is add my square bracket and put in a quotation mark and say ID. So now when I go ahead and I save that and I run it, you can see that it output just the one piece of information from that dictionary that I wanted. And I can change this, obviously. So I can say first name. Okay, and save that. And let's run that. And you can see that I went and I got a return value of John. What I want to do now is move on to something very important, and it is called scope. And almost all programming languages that I can think of deal at some point with scope. And whether or not you understand it now, you've also, throughout these tutorials, have been dealing with something called scope. I want to introduce this idea of scope. Now, you've already been using scope. You may or may not be aware of it, but you have actually been implementing it a little bit. And when we look at a function as an example, and we've got this function called welcome that we've defined, everything after that colon is indented and it goes into this code block. And you can see by the thick border that I've put inside the code block, what that implies is that everything can be processed inside that code block. And there's no real in or out per se into that code block. Okay, that's a reserved space inside the function that everything is doing all of its calculations in. So for example, if I have this message and it is initialized to the word hello, and I want to print that out as part of my function, I want to print that out. And if my print function is on the outside of my code block, my actual welcome definition is not accessible. Okay, so print message, calling that print message function would not be actually accessible to the print function. The only way that could happen would be is if I were to move my print function inside my code block. And some other languages are very, very explicit in the way they define a code block. They use brackets. But in Python, what we're doing is we're using the semicolon and indentation to define the brackets. That's something you'd see in other programming languages. But here, Python keeps it nice and clean. So let's go over to Visual Studio and do some examples with scope. Now you see that I've already created this function in Visual Studio. And if I save that, and now suppose what I want to do is, like I said before, I want to try to print this off. And I'm going to run this after I save it. And you can see that I'm going to get this error. And what does this error say? And the error is actually on line 5. You can see the line underneath it. And it says name message is not defined. Okay, so you don't see anywhere on here where it actually mentions the word scope. Okay, you get another, it's a warning. This one is a warning. And if you look down here, you can see there's one error and one warning. And the yellow line is just a warning to say, hey, you haven't used this variable yet, so why do you have it? And it's not until I change my indentation on line 5 where I move this print function back up closer. So if I actually move it down here, now you're going to see when I save this that the error goes away and so does the warning. And the warning is now going to be used inside the print function on line 3. Okay, so the way we're defining our scope, which is really access to lines of code that we want, we have our colon and we have our indentation. And like I said earlier, some other programming languages that you might be familiar with actually have this. This is how you would define scope, but Python takes care of that for us, so we don't have to worry about it. So if I want to run this code, now we're going to see that we get this outputted message. But of course, like I said in the past, I can't actually see the message right now because I have not called the function. So if I go down now and I go out of the scope of the function. Now I can call the welcome function, and you can see that it's picking it up in the IntelliSense. Okay, so now I can go ahead and see this. So I'll save it, and now I can run it, and it says hello. Okay, so it's really important you understand this concept of scope. So what I want to also mention is something else about the variable. So message is the variable, and this variable is referred to as a local variable. It is local scope. Okay, and you'll see variables in different locations, and those will be referred to as a global variable. So for example, if I want to type in age equals 50, this is now globally defined. So the scope of this is that anywhere inside my program, we can refer back to age. Okay, so anywhere in there. If I want to go to here and I want to say print now age, this is now globally seen throughout the entire program. But in this particular case, this is considered locally available. This is a local variable or local scope. Okay, so if I go ahead and I run that and I save it and I run it, you can see here that I'm printing out the local variable value and I'm printing out the global variable value. So it's important you understand there's a difference between a local variable and a global variable, okay? And the definition of them really becomes where in scope do they reside? Okay, local variables typically go inside a function. Global variables are found outside of a function. Now, let's look at something really interesting. And I'm going to copy this one, and I'm going to go down and paste it, and I'll save it. And you can see that because of the indentation, that's causing a lot of errors, a lot of confusion. But suppose I do this, and I'm going to change the name of this function, and I'm going to say hello. Okay, this is now my say hello function. And when I save this, you're going to see this error change. And you're going to ask yourself, well, how is it that I can have a variable up here called message and a variable down here that says message? And I can change this message to be hello Tom. Okay, so how can it be that I'm creating the exact same variable? Well, it goes back to this idea of scope. The only thing that can be seen inside this say hello function is whatever happens inside this indentation. So now if I were to, I'll get rid of this and I'm going to call my say hello function. Okay, and you're going to see the difference between the two. And I'll clean it and run it. And you're going to see that hello and hello Tom, even though these are the identical variables, but these are local variables that reside inside each of these functions. Okay, they have nothing to do with what's happening out here. Okay, so when they're sort of hidden or confined to their scope, you have a little bit more flexibility. And this is why naming conventions are going to become so important for you. Because if you're working in a team and you don't really, as a team, consider what your naming conventions are, and let's say 5 developers are on this project and everybody's naming the same thing, message. Okay, if your naming conventions are bad, that's going to cause a problem throughout your entire application. But as long as it's in scope, then it really doesn't matter. It sort of resolves that issue for you. Now, the last really important thing that I want to say is when the interpreter goes from the top down and it's reading this code, once it goes out of scope, it's completed its functionality. What it's going to do is it's going to remove or release the memory storage. Okay, and that's actually referred to as garbage collection. Okay, so right now in memory, when I run this the first time, it is storing in memory the word hello. But once it executes this function call and it's done and it's moved on to the next item, it's actually going to release that block of memory on your hard drive. Okay, so it's really important that you understand is once you go out of scope, it actually deletes everything that's in that memory and releases it back to your computer. Okay, really important to understand that little fact as well. Now, and I want to further emphasize something, is that global variables do not typically get garbage collected. Okay, so I want to caution you about something with global variables. If you're going to use global variables, they can have unintended consequences to your application. So you have to really be very, very judicious with the way you're using global variables. You can use them if you're setting them as something that you absolutely don't want to change. Okay, but just keep in mind that global variables are very unlikely to go out of scope, therefore be collected in garbage until you actually close out your application. Okay, so just whenever possible, try not to use global variables. Try to just use local variables inside of a function or a class. One of the absolutely most important skill that you need to develop as a good software developer is the ability to debug code. And I'm going to show you some methodologies that we can use to debug code inside Visual Studio. And it's somewhat common to do it in this way in other IDEs as well. But I'm going to show you how to do this. I'll give you the principles of debugging in Visual Studio Code right now. And it's the last thing that we're going to actually do in this video, but it's a really important thing, so I've saved it to the end. So you can see here that I have this function that we have done previous to this. And what it does is it actually takes our numbers. We pass in a tuple or tuple, depending on how you want to pronounce it. And what it's going to do is output the number 6. Okay, but there's no errors in this particular multiply function right now. But what I want to do is actually introduce an error. But let me just show you that it runs. And you can see that the output is actually 6. So I'm going to close this off and I'm going to introduce an error. Okay, and I'm going to tab this in and I will save it. And notice that I'm not getting any warnings or errors. If you look down at the bottom, I have no problems at all. Okay, so this is why this is different. This is debugging. It's not functioning the way I want it to function, and I want to know why. So if I run this, what happens? And you can see that my output is 1. Okay, so clearly I'm not getting the intended consequence of this function. Now, as we just saw, what I really want it to be is 6, but I know that after testing this that I'm getting the wrong output. So that's why we have to get into debugging. Okay, so let's go ahead and do that now. So what I want to do is just clean up my screen a little bit. And you can see over here that there's a little bug icon with the run. And I'm going to click on that right now. And you can see this thing, it says create a launch.json file. And so what I'm going to do is actually click on this, and then it says Python file, debug the current active Python file. So I'm running that now. And you can see that in all of this Python stuff, there's this JSON file, and we're not going to worry about that for now. But what I'm going to do is just close that down. And you can see now on the side of the screen, there is this little window for variables, for watch, and my call stack. But you can see in here, if I drop this down, you can see that in our VS Code that this file was placed in here, this launch.json, same with our settings. But I'm just telling you that to make you aware that it's there. Don't really worry about it right now. So let me close that back up again. But now when I want to open up that window again, I can just click on this little icon here, the bug with the little triangle or the play button. Okay. Now, the one thing I want to show you, and I'm going to slide this over so we can see it a little better. This drop down here, this is configured for our Python file. And there are different ones down here that we could have probably looked at, but for now we're going to stick with this Python. Okay, we'll leave that there. And I'm going to slide that back over because I want more space on my screen. Now what I'm going to do is go up to line 7 and I'm going to do print. And in here, I'm just going to begin. So that's where I'm going to put that line there. So I want to save that there. And if you notice when I hover my mouse over the line 8, you see this little red dot. And that's one thing I can do. I can actually insert something called a breakpoint. And I'm going to show you how a breakpoint actually works. You can actually press F9 in there too. So if I'm on that line and I press F9, the breakpoint goes away. And I think it's the same on a Mac as well. But I'll go F9 to create my breakpoint on the line that I want. Actually, for a Mac, it is the function key plus F9 to use that breakpoint. And in Windows, it's just F9. Now, if I want to run the application up to line 8, what I can do is actually press F5. Okay, and you can see what's happening. It's running it up to this point, and a whole bunch of stuff has just started to happen, right? The important thing is you can see that I get this little menu bar at the top here. And this is F5. This is to continue. This is step over. This one is step into. This one is step out. And this one is to restart. And then finally, this is to stop doing my debugging. Okay. And you can see that right now my little red dot has changed to this different shape, this different icon here. And that tells me which line my compiler is now sitting on. This is the place that the compiler ended up. Okay, and it's just sitting there right now waiting for further instruction. Now, what I'm trying to do is open up a window into the compiler's little world and see what's going on. See what the compiler is doing in order to execute all of this code. How is this code being processed? And this is what I'm able to do, because when we run an application, that happens in real time, meaning it is happening just in a linear timeline fashion, just like you listening to me in the last 2 seconds. It's very linear. And the compiler does the same thing. But what I can do is I can slow that down and I can go line by line and see what the compiler is doing. Now I can go up to the top and I can hit F10, or I can hit this little icon. And I'm going to click this icon, this step over, and it means step over the line that it's in. So I'm going to click on that there. Okay, and then you can see I've now gone into line 9. Okay, and that's what I'm doing. And look at my output at this point right here in the debug console of my terminal. You can see that it has stepped over line 8 and it is printed to the screen. That was the previous action that it had taken. So if you remember in our dilemma, we were getting an output of 1 instead of 6. We know that we want it to actually execute all those numbers and give us a 6. But for some reason it got a 1, and we're trying to use this to figure out why. So I'm going to step over this again, and you can see in the output that it's a 1, okay? But then the application's stopping. It's ending, and I don't understand why. Why did it stop? So I want to find out what's going on. So what I'm going to do is I'm actually going to go over to this Python, and I'm going to click that again. I'm going to run it again. Okay, so I'm going to click on that and you can see that it opens up again. And I click the little button and you see now my menu bar opens up again. And instead of stepping over, what I want to do is it's going to step over, but then I want to go into my multiply function. So I can either press F11 or just click the down arrow, this step into. So I'm going to step into the next line, and then I'm going to find out what is going on. Okay, so let's continue. And again, what I'm doing is I've stepped into this function, and now I can do, again, the F11 or step into. And what you can see is the little icon has moved up into my multiply function. So I told it go into here and then step into that again. Okay, so now what it's doing is you can see over in my variables, in my local variables, and you can see it's defined it by local or global variables. And right now what it's saying is I'm going to go in and have a look at your local variables. Okay, and it's because it got picked up when it went into after this line, and it knows that there are some local variables in there. And when we look over in the local, and we can see here, I highlight my cursor over it, and it tells me it's a tuple. Okay, so that's good information for me to know. And you might be asking, well, why doesn't it see total, the variable total? And it's because it's not really defining the current line that this little icon is on. It's not until I step over it. And you can see numbers here because I've stepped over it. So what I'm going to do is I'm going to go to F10 and I'm going to step over line 2. And you can see now that total is defined as 1. Okay, I'm in the next line and it's displaying what my previous line was for me. And now I'm at the beginning of my for loop. Okay, so this is where it's going to get interesting for us because we suspect that that's where the problem is. In fact, we know it is because we created the problem to begin with. So I'm going to step over, and you can see now that in here, I've got my numbers again and my totals. And now this local variable number has come back to the top and it's been updated. And now let's step over this one more time. Okay, and nothing really changed. We just know that we've got number 1 up there is the new value. We've got this tuple identified and we've got total. And if I were to kind of hit this little icon, I could find out some more detail about it, but I don't need it for now. Okay, so let's keep going. So what is the intention of this function? The intention of this function is to keep doing a loop until we have exhausted all of the numbers in the tuple. So let's jump over one more time. Let's see what happens. Because the expectation is that it returns to the for loop and it starts to increment. Okay, so let's step over again. And look at that. Look at what happened. It actually exited out of the function. And I want you to understand, I talked about scope previously and the lifetime of variables. You notice here that it no longer holds on to any values related to my local variables. This is when I was talking about garbage collection. So they were eliminated right off of the stack. They no longer exist as far as the computer is concerned as stored memory. They were cleaned up, okay? So what does that mean for us? It means that this function is as we stepped through it, we realized there was something wrong in the way we wrote that code, okay? And the thing that we know is wrong, because again, we created the error, is that our loop only went through one time and then it exited. This is not what we intended originally. Okay, so while it doesn't give me this big flashy warning sign, it does give me lots of clues. I can see what my compiler is doing. Okay. Okay, so I'm gonna go through this again, and if I want to stop my debugger, I can do Shift F5, or I can just click on the little button here to stop the debugger, and that's what I'm going to do. And so now what I'm going to do is I'm going to go back and I'm going to fix the error, and I'm going to save it, clean this up, and now I'm going to run through it all again in debug mode. Okay, so my debugger has started. And I'm going to step over the first line. And now I'm saying, okay, great, begin. That's exactly what I wanted. Now I want to step into my function. So I'll press F11 or the icon. And I do that, and you can see that numbers right away is identified here in my local variables. And from here now, I'm going to step over that. Okay, and now you can see totals is redefined. It's in there as a local variable again. So this code block shows me that I have two different local variables. Okay, and I'm gonna step over that again. And so far so good. And now I'm gonna go back. I've hit the return. I go back to the top of my for loop and I'm gonna step over again. And now you can see that my number is now updating. Okay, so that's working properly. Let's step over that one more time. Okay, and you can see it's updating again. Okay, and the previous total, because I haven't got to that, I haven't got to line 5 and updated it. What it's saying is, hey, go and run through the third iteration here, and totals will have to, the next time around, have to be updated. So I'm going to step through again, and you can see that totals now is equal to 6. And I've gone through my third and final number. And then what happens? Step over, I go to return total. And you can see now I've met all of the conditions of my for loop, and my program is executed exactly how I wanted it. And I've got the exact output, and it has terminated the actual function call, and you can see all of my variables have been cleaned up. Okay, so this is how we do debugging, and these are the tools that we can use if we're not getting any sort of signal from the console that we have a problem or an error or anything like that down here, but we know that it's just not working. We've tested it and the output isn't working. So this is what we can do if we can use the debugging tool. So anyway, again, that's another long video, and we've done a lot of content today. And what I'm going to do is end the video and just thank you for watching. And if you've gotten to this point, good for you. You're doing great. And I do appreciate that this literally like drinking water from a fire hose. It's just going to take some practice. Remember, you can't go to the gym and cram all night and expect the next day you're going to come out looking like Arnold Schwarzenegger. It just doesn't work. So anyway, I'll see you in the next video. We're going to start talking about data structures and arrays and stuff like that. Okay, so thanks again, and I'll see you soon.